Hello, my dear students. Today I am going to discuss hydrocarbons, class 10. This hydrocarbon chapter of class 10 is very important topic which will support you, which will help you to understand the organic chemistry in higher level. If you are interested to study chemistry in higher level, this chapter is very important for you. I will make you understand the basic concepts that are required to understand the organic chemistry in this hydrocarbon chapter, and we will also discuss the important topics that are in class 10 hydrocarbon chapter. So let's start this hydrocarbons with the introduction of carbon. First of all, we have to understand about the carbon, then only it will be easy for us to understand about the hydrocarbon. What is carbon? You know, carbon, its symbol is C. Its atomic number is 6. Its electronic configuration. If we talk about the cell electronic configuration, then it has two cells. They are K cell and L cell. In K cell, there are 2 electrons. In L cell, there are 4 electrons. If we talk about its subcell electronic configuration, then its subcell electronic configuration is 1s2, 2s2, 2p2. Now, after electronic configuration, this carbon lies in which block of the periodic table? By looking this, we can say here the last subcell of carbon is P. So it lies in P block. After block, which group? In which group carbon lies? You can see here, since it lies in P block. How many electrons are there in P? There are 2 electrons. So to find the group number, we have to add this 2 in the number of groups in S block and D block. It means the group of carbon is 14, 14th group, or we can also write this 14th group as 4A group. 14th group is known as 4A group. After group, in which period carbon lies? Period means the number of cell. How many cells are there? 2 cells, so its period is 2, or largest coefficient in the electronic configuration if subcell electronic configuration is given. So this is the period. Now valency. Generally, valency is equal to the group of that element. What is the group here? 4A. Or valency means the number of electrons in the outermost cell. So what is the number of electrons in the outermost cell here? 4 electrons are there in the outermost cell, so its valency is 4. That means carbon is tetravalent. Tetravalent element. Since carbon is tetravalent, generally carbon shares 4 electrons with other atom, and it forms covalent bond. You know, there are 2 types of bond, ionic bond and covalent bond. This covalent bond means what? If a bond is formed by sharing electron, then such a type of bond is called covalent bond. So carbon generally forms covalent bond. Now, this tetravalency of carbon and its small atomic size makes the carbon to form a long chain compound. Like one carbon can connect with several other carbons and it can form a long chain compound. This kind of property is due to its tetravalency and due to its small atomic size. This is also known as catenation property. Catenation property. So after knowing these things about carbon, now let us start what is hydrocarbon. These hydrocarbons, here by the name we have to understand its definition. The compounds formed by the combination of hydrogen and carbon are known as hydrocarbons. Hydrocarbons. Now these hydrocarbons, they are basically classified into two types. They are, number one, saturated hydrocarbons. Number two, unsaturated hydrocarbons. Let's talk about saturated and unsaturated hydrocarbons. So first of all, saturated hydrocarbons. Saturated hydrocarbons. This word saturated means, in chemistry, if there is any solution in which we cannot add furthermore solute without increasing temperature, then such a solution is called saturated solution. In the same way here, saturated hydrocarbon means the hydrocarbons in which further reagent cannot be added easily. They are more stable. Then such hydrocarbons are known as saturated hydrocarbons. Now, what is its definition? What is the definition of saturated hydrocarbon? The hydrocarbons in which there is single covalent bond between the carbon atoms are called saturated hydrocarbons. Saturated hydrocarbons. These saturated hydrocarbons, they are more stable and less reactive. By the name, it is clear they are saturated. That is why they are more stable and less reactive. Since they are less reactive, it is very difficult to add any further reagent. We cannot add any reagent easily in them. Then these saturated hydrocarbons, they are also known as alkanes. They are also known as alkanes. Known as alkanes. Now the second type, that is unsaturated hydrocarbons. What are unsaturated hydrocarbons? Unsaturated hydrocarbons. Again, the word here unsaturated means what? You know, unsaturated solution means any solution in which there is a deficiency of solute. It means we can add further more solute in that solution without increasing the temperature. Then such a solution in chemistry is known as what? Unsaturated solution. But here we are talking about unsaturated hydrocarbons. It means what? The hydrocarbons in which we can add a reagent easily without any change. We can add a reagent to them. It means they are more reactive and less stable. But in saturated hydrocarbon, what? They are more stable, less reactive. Now, unsaturated hydrocarbons, how can we define them? The hydrocarbons, the hydrocarbons in which there is a double or triple covalent bond between the two carbon atoms, are known as unsaturated hydrocarbons. Now, here we can write that they are more reactive and less stable. Unsaturated hydrocarbons they are more reactive and less stable. We can easily add a reagent to them. So this is about the saturated and unsaturated hydrocarbons. Here in case of saturated hydrocarbon, what is there? The main thing that we have to remember is they have single covalent bond. Whereas in case of unsaturated hydrocarbons, there may be a double covalent bond between the carbon atoms, or there may be a triple covalent bond between the two carbon atoms. So this line represents covalent bond here. Don't get confused by looking this line. This line is the symbol of what? Covalent bond. If there is one line, that means one covalent bond. If there is two lines, that means two covalent bond. If there are 3 lines, that means there are 3 covalent bonds. So these unsaturated hydrocarbons, if there are two covalent bond between the carbon atoms, they are known as alkenes. If there are 3 covalent bonds, then they are known as alkynes. But saturated hydrocarbons are known as what? Alkanes. Whereas unsaturated hydrocarbons are known as alkenes or alkynes. After this, let's talk about the basic that we have to know before talking about alkane, alkene and alkyne. We require certain basic things before starting this alkane, alkene and alkyne. IUPAC nomenclature. International Union of Pure and Applied Chemistry nomenclature. This is an organization which gives the name of different chemical species, and it has certain system of nomenclature for the hydrocarbons. How do we give name to any hydrocarbon? Here we have certain system or rule. So what is that system? What is that rule? Let's try to understand. While writing the name of any hydrocarbon, we have to follow this rule. We have to use prefix, root word, primary suffix, and secondary suffix. Secondary suffix. So what is this prefix? Prefix means generally if there is any substituent in the hydrocarbon like chlorine, fluorine, bromine, ethyl group, methyl group, nitro group, or any other substituent, then those substituents are written before the name of that organic compound, and that is called prefix. Now the second one is the root word. This one you have to remember and you have to understand so that you will be able to write the name of any hydrocarbon. This root word decides the name of the hydrocarbon. Now, it depends upon the number of carbon atom, number of C atom present in any hydrocarbon, and the root word used or word root, anything you can say. Here, if there is only one carbon, that means carbon number 1, or then the root word will be meth. 2 carbons, root word eth. 3 carbons, root word prop. 4 carbons, root word but or but, whatever you call. C5 means 5 carbon, root word pent. 6 carbons, root word hex. 7 carbons, then root word will be hept. 8 carbons, then root word will be oct. 9 carbons, then root word will be non. 10 carbons, then root word will be dec. So my dear students, after the root words that we have to remember, the next thing that we have to see after the root word of organic compound or hydrocarbon is primary suffix. This primary suffix basically depends upon the number of covalent bond present between the carbon atoms in the parent chain of that hydrocarbon. If there is single covalent bond, in that parent chain of hydrocarbon. For that, we have to use the primary suffix ane. If there is double covalent bond between any two carbon atom of parent chain of that hydrocarbon, then we have to use the suffix ene. And the third one is if there is a triple covalent bond between the carbon atom, any two carbon atom, then we have to use the suffix yne. These three are the primary suffix that we must not forget while writing the IUPAC name of any hydrocarbon or any organic compound. After the primary suffix, the next one is secondary suffix. Here this secondary suffix depends upon the functional group. Functional group. This functional group means any atom or group of atom present in the organic compound that determines the chemical property as well as physical property of that organic compound. There are many functional groups and every functional group have their own kind of secondary suffix. So my dear students, here some of the functional groups are like alcohol. Alcohol functional group has the formula OH and it has the suffix ol. This is OH or hydroxide used for the alcohol functional group, and the secondary suffix in that case is ol. If there is a carboxylic acid, the formula of carboxylic acid is COOH. And for the carboxylic acid, we use the suffix oic acid. If we have aldehydes functional group, that means COH is the formula and ol is the suffix used here. Suppose we have a hydrocarbon here like this. First of all, let's see the number of carbon atom, and suppose we have here the functional group OH. In this case, while writing the IUPAC name of this compound, what we have to see first, we have to count the number of carbon atoms present in this hydrocarbon. 1, 2, 3, 4, 5. There are 5 carbon atoms. So first thing that we have to do is we have to write the root word. Pent for 5 carbons. 1, 2, 3, 4, 5. After that, we have to choose the primary suffix. There is single bond only between the carbon atoms. There is no double, no triple bond. As there is single bond, what we have to do here? We have to use the suffix ane. And this hydrocarbon, as it contains a functional group OH, now we have to use the secondary suffix also. What will be the secondary suffix here? Plus OL. Since there is OH group, alcohol functional group, we have to write OL. Now, one thing that we have to be careful here while writing the IUPAC name is if the first letter of the secondary suffix is a vowel, then it replaces the E of the primary suffix and it becomes like pentanol. Here this E is replaced by this first vowel letter. If there is vowel, then only we have to do like this. So the name of this compound is pentanol because it contains OH functional group, and here OL suffix is used. In this way, we have to write the IUPAC name of any organic compound by using this simple formula. Now after this IUPAC name, let us talk about the hydrocarbons. The first one is alkane. What is alkane and how we have to write their name, molecular formula, structural formula, and condensed formula of some members of alkane. We will discuss that. Now we have alkanes. Here alkane means what? We know that the saturated hydrocarbons in which there is single covalent bond between the carbon atoms are known as alkanes. They are also known as they are also known as paraffins because they are more stable and less reactive. Their general molecular formula, their general molecular formula is CnH2n plus 2, where N represents the number of carbon atom. Now I will give just a simple trick to remember this general molecular formula for alkane, alkene and alkyne. And how do we remember which one have single bond, double bond or triple bond? Let's see here. We have alkane, alkene and alkyne. Three groups of hydrocarbons. The number one is alkane, number two is alkene, number three is alkyne. Serially you remember, or you can remember the alphabet. Alkane first letter is A. First letter in the suffix is A. Alkene, the first letter of the suffix is E. Alkyne, first letter of the suffix is Y. Alphabetical order of this suffix we have to remember. A, E, Y. So first A comes, then E comes, then Y comes. So in this way, 1, 2, 3. Now, alkane, as it comes in number 1, there is single bond between the carbon atom. Alkene, it comes in 2 number, so there is double bond, double bond. And alkyne comes in 3 number, so there is triple bond, triple bond. Now, how to remember the formula, general molecular formula? So first of all, here you see the 2 number alkene there is. So write here CN H, here is 2, so 2N. CnH2n. You remember this one. This Cn is same everywhere. You write here also Cn, here also Cn. In this alkene, what is there? H2n. Now, if we go in one number, then you write H2n, same here. Here you write plus, here also you write H2n, but here minus 2. In this way, you can remember the general molecular formula. If you will remember the general molecular formula, it will make you very easy to write the molecular formula of any member of alkane, alkene or alkyne. By the help of this general molecular formula, you can write the molecular formula of the members of alkene, alkane, alkyne. Now let us talk about the alkanes and their members. Some members of alkane. Members of alkane. Now, as you can see, here is A. Number 1. It means there is single covalent bond. You write here, single covalent bond. Then general molecular formula GMF is equal to CnH2n plus 2 and the suffix ANE. Now let's see some of the members of alkane. Number of C atom, name, molecular formula, structural formula, and condensed formula. Condensed formula. Now here, the first one, the first member of alkane contain only one carbon. That means N is equal to 1. If there is only one carbon, what will be the name of this alkane? As you know, if there is one carbon, then we have to use the root word meth. Since it is alkane, what is the suffix to be used? ANE. Name will be methane. What will be its molecular formula? C1. If there is one, we do not have to mention in molecular formula, because if there is nothing written here, it means there is one in case of molecular formula. So C H, how many? N is equal to 1 here. So H, how many will be there? H, 2 into 1 plus 2. It means 2 into 1, 2 plus 2, it is 4. H4. CH4 is the molecular formula of methane. After that, structural formula. There is one carbon, write this one carbon. And we know that a carbon has tetravalency. It means its valency is 4. So it can form 4 covalent bond. So you make 4 covalent bond around this carbon and connect hydrogen in each covalent bond. This is the structure of methane. After the structural formula, condensed formula. Condensed formula means what? Condensed formula means number of hydrogen or other atom with each carbon in the structural formula. Now you see here, there is only one carbon, and around that one carbon there are how many hydrogen? 4 hydrogen. So CH4 is the condensed formula. In this case here, molecular formula and condensed formula are same, but in other cases it will be different. See number 2, C2, N is equal to 2. If N is equal to 2 or if there is 2 carbon, what will be the root word here? Eth. Since it is alkane, write ANE, the primary suffix. Then what will be the molecular formula here? C2H how many? Here multiply by 2. It will be 6. C2H6. Now you make 2 carbon atom. First of all, between the 2 carbon atoms, place a single covalent bond and complete 4 bond around each carbon atom. Like here we have 1, 2, 3 and this bond total 4. In the second carbon also 1, 2, 3, 4. So here also you write like this, connect hydrogen in each covalent bond and you will get the structural formula of ethane. After the structural formula of ethane, condensed formula, you see there are 2 carbon. In the first carbon, how many hydrogens are connected here? 3, CH3. In the second carbon, how many hydrogens are connected there? 3 hydrogen. So this is the condensed formula of ethane. The next one is third member having 3 carbon, N is equal to 3. It is propane. C3H, how many there will be? 8. Now make 3 carbon, 1, 2, 3. Between the carbon atoms, place single covalent bond, 1, 1. Now around each carbon, complete 4 covalent bond. 1, 2, 3, 4. This carbon 1, 2, already 2 bonds are there, 3, 4. This carbon also 1, 2, 3, 4. Connect hydrogen in each covalent bond and complete the structure like this. Now you see the condensed formula. There are 3 carbon atoms. In first carbon atom, how many hydrogen are there? 3. CH3. In second carbon, how many hydrogen atoms are there? 2. CH2. In third carbon, there are 3 hydrogens, so CH3. This is the condensed formula of propane. After that, butane, C4. N is equal to 4. Name butane. C4H how many? Place here 4. It will be C4H10. Now make 4 carbons. 1, 2, 3, 4. Place single bond between the carbon atoms. Complete 4 bond around each carbon atom. Not more than 4, not less than 4. If you will make 5 bond around each carbon, that will be wrong. If you will place only 3 or only 2 covalent bond in carbon atom, that is also wrong. So remember one thing, there must be 4 covalent bond around each carbon atom. Now connect hydrogen in each covalent bond to get the complete structure of this butane. Now here also we have to write the condensed formula. In first carbon there is 3 hydrogen. In second 2 hydrogen. In third 2 hydrogen. In last 3 hydrogen. So this is the condensed formula. In this way, you can write the molecular formula, structural formula and condensed formula of pentane, hexane, heptane, octane, nonane and decane also. So in this way, we have to write the name, molecular formula, structural formula and condensed formula of any member of alkane. So after this, we will discuss about the alkenes. Now what happens in alkenes? Let's see.